Hello everyone, it's February the 7th. Alright, let's see, what do we have? Design a number container system. Design a number container system that can do the following. Insert or replace a number at the given index. Return the smallest index for the given number in the system. Implement this. Initialize it. Change fills the container at index with the number. If there's already a number at the index, replace it. Find number returns the smallest index for the given number. And -1 if there's no index that is filled by the number. Okay. Example. Find 10. 10 does not exist, return -1. Change 2 to 10, so index 2 will be filled with number 10. Change 1, 10. Index 1 will be filled with number 10. So 1, 2, 3, 5 will become 10. Find 10, so it will return 1, right? Because the smallest index is 1. Now the index 1 is filled with 10, and then we change 120. So index 1 will be filled with 20. Find 10 should be 2. Okay. So essentially, we need one map from index to the number. I wonder if we really need that. Index to the number. And then for the number, we need to keep track of what indices it is. And we can return the smallest index. And the smallest index sounds like a heap, right? We can use heap to do that. Yeah, we can use heap to do that. But we need to also verify that. Okay, so basically we have what is the number? Number is 10 to the 9th. So we have an array for all the indices, 10 to the 9th. That would use to do the number. And then what we're gonna do is we'll set up also a map with number and a heap. So every time when we change at the index, we push the index to the heap corresponding to the number. And if we change it again, we just put it in. And when we need to find, we go there and then we start pop. And we pop the smallest, and we need to check if it is correct. So that will work. Runtime is hard to say, but amortized runtime shall be log n for the find and O1 for the push. Okay, so basically we're gonna say do we need private for this? I do believe we have to have, right? Private. We need to have an int, a vector of int. Call it, what do we call it? Indices. Index to, so index to num. And we need a map. Map is going to be int, and that should be std priority queue int. This will call it num to index. Right, so I have both. Now we just say index to num forgot. How do I do that? Class constructor. My class brand. Okay, so that's makes sense. How about vector? New. That's how you do it. New. New. We'll do new. New. std. Vector. Oh, actually, we can directly do this because we don't know the size. So we can just say 10 to the 9th. 2, 3, 4, 5, 6, 7, 8, 9. Everybody's -1. Right? Everybody's -1. And this we don't, so we don't have to do anything here. So find if index to num number is smaller than 0, return -1. Doesn't exist, right? Otherwise, it exists. Then we go for change. While num to index number is not empty. And index to num number, that's the index, is not equal to number to index hold a second. So I shall equal to num to index number dot top. Right. If index to num I, right, that's not equal to the changed number, then we will do num to index number dot pop. Else, if it's equal, then we will return I, right? Which means that is what we want. And resonance element function must be called. What do you mean to call it with no argument? I thought expected. I guess we cannot do it this way. So we have to do it this way. Index new td vector int 1 2 3 4 5 6 7 8 9 -1. Huh. was following this, but I don't think it works. Oh, look! This is the way. I see. Okay, that makes sense. So we basically say this a colon. Okay. Colon index to num. Right? Okay, so now that's that. Eventually we'll get out. Well, once they get out, we'll always return -1. It shouldn't reach here. Should not reach here anyway. Okay, here is the change. I basically say num to index. No, index to num, right? Index to num. Index. Shall I put the number? And num to index number dot the insert push add. Wait, what the hell? Push index. Okay, something is not right. I think I'm not allowed to do it that way. Alright, we need a new help. Maybe don't do private. I don't think that'd make any difference. I have no idea. Oh, I think I forgot the... There we go. That's the way. Huh. use a heap as a map to keep track. Use a map of integer and heap to keep track of each number's indices. Top of the heap is the smallest index. However, to make sure that the index does point to the number of interest, we use another array to keep track of the indices of the number of what number is at which index. Okay, let's run this. Memory limit exceeded. Oh, now I remember. Yeah, we cannot do that. Well, that's actually make it much easier. I don't even have to do any of those things. And index has to be 1, so if it's equal to 0, then that's bad. Do I have to do this? Oh, this is not right. We give me a number. I have index to number. This is not right. No, it's number to index, right? If it's empty, then if it doesn't have, which means it just does not have, so make the -1. Hold a second. I think we need a new okay. Right, so we check it's empty. If it's not empty, then we'll do this. But if index is not right, then we will keep going. Instead of doing this, we'll keep going. Keep going, keep going, keep going until this one exhausts, then you will return -1. So this is actually we're gonna hit here. So this shall be right. Ooh. Oh, I see. So we do have to say else. But else it just break. Which means we are the... Oh yeah, that's right. I have no idea why I delete this code. It should return I. Because it's equal, then this is the smallest. Okay, what the hell? Oh, I think it's a max heap. God, Lord. So I think it's this td greater int like this. Or maybe this. Screw you. That's fine. I'll push the negative index in it. Then we do negative. Yep. That should be right. Yep. Solid. Solid 137. Huh. Oh, and login for file. Yeah, that's how I imagine this as well. Wait. Find O1 for change. Yeah, I should also be O log n though, because you have to insert. Okay, so we're done with this. We check a tutorial. 2 maps. Ooh, I think you can, because the map is sorted, right? Private. No, it's unordered map. Oh, it's a set. Oh, I think it's keeping. Wait, hold on. No, that's not right. Wait. Set is ordered. I get a previous number. Previous number erase index. It's already sorted. Min heap with lazy update. Oh, priority queue int. That's what it's supposed to be. That's greater. Oh, for us, we can do unordered map. I think you were just talking about unordered. Faster being faster than the other one. Oh. See the difference? Should remember to use unordered map. I think very few scenario you will actually use the other way around, because in general you don't need. I'm not used to map being ordered anyway, so it's better use that. Oh, that's what lazy means, because I don't keep it in check immediately, right? Lazy update. Change, that's exactly the same. The other one doesn't exist. I mean, keep empty, we get an index. If not, we'll pop. Which actually is, yep, I can do it the other way, but it's fine. Okay, that's right. Sorted set. All right, that'll be it. Can I do another one? Of course. Do I want to? Of course not. Let's lift some 90% today. I have 3 singles and 90% for both snatch and clean and jerk. Looking forward to it with snatch, but not so much with clean and jerk. Shoulder still hurts.